now we'll see how to product A matrix and B matrix. Okay, so once again I will write the same matrices in the next page. So A matrix I have, what is that, 1 2 3 and 4 5 6. What is that, 4 5 6? This is the A matrix. And B matrix, what we have, yeah, 1 3 5 7 9 11. 1 3 5 7 9 11. So order of the matrix, here 2 rows 3 columns, here 3 rows 2 columns. This is we have. So already we have checked in the previous page whether it will be exist or not exist. Okay, so it is a exist. It means first matrix column, second matrix row are same na, then only it is a exist. Answer also this will be 2 by 2. It means 2 by 2 answer you are going to get. Okay, 2 by 2 answer you are going to get. That will multiply. First AB, which is equal to, we have to write as it is. Listen children, if you understand this, then only exercise and all it will be very easy. Otherwise it will be tough. So kindly listen what I am doing. Okay, we have to product row with a column. Take a first row, multiply with each column. Listen carefully. See, I'm going to take a row. See, there are 2 rows, first row and second row. First of all, I'm taking a first row. I'm going to multiply with each column. Okay, listen how I'm going to do. First element must be product with the first element. First element must be product with the first element. Listen carefully. First element of the first matrix, first element of the second matrix. But in the first matrix, we have to see row wise. In the second matrix, we have to see column wise. That is very important. So first element product with the first element. It means 1 into 1. You write that 1 into 1. 1 multiply 1. Okay. Plus when I go to second element to second element. Second element to second element. I should give plus here. Okay. So that 2 multiply 5. Again plus when I go to third element. Okay. 3 into what I will be getting? 9. 3 into what I will be getting? 9. So 3 into 9. So here also elements over, here also element over. Now leave that. Okay. Stop your product. Then go to next column. Means second column. Same first row. I'm going to multiply with the second column. Understand? That's it. Now first element again. In the second column, first element. When I go to second column, you should leave a gap here. Don't put a plus here. Okay. This is for a first column. Over. I'm going in a second column. Here I will be writing. Understand? Very important. Okay, very important. Second, what is that column when you go? You must be very careful. So leave a gap. First element means 1 3s are. Okay, 1 3s are 3. Next plus. Second element of the first row. Second element of the second column. Okay, so 2 into 7. 2 into 7 plus. Like that third element. Okay, 3 into 11. 3 into 11. So elements are over. Stop here. Elements are over. Stop. Very important thing. I took first row. I multiplied with each column. Suppose third column if you have, you should multiply. Fourth column if you have, you should multiply with the same row. Okay, like that you have to go. Be careful here. Right, fine. Next, I'm going. I'm going to second row. Second row you take, multiply with each column again. What I did now, the same thing you have to do in a second row also. So first element of the second row, first element of the first column. Again the same procedure you have to go. So first element 4, multiply first element what pa? 1. Okay, multiply plus. When I go to second element, you should put plus. Okay, 5 into 5. 5 into 5. 5 multiply 5 plus. Okay, third element to third element. What you will be getting? 6 into 9. What you will be getting? 6 into 9. That's it. Here also element over, here also element over. When all elements got over, we have to go second column. Same row, we have to multiply in the second column. Second column now leave the gap. For column, we have to leave a gap, right? So that 4 into 3. Okay, 4 into 3. So that 4 multiply 3. But I go to second element, you should put a plus. Second element to second element. Second element to second element means 5 sevens are 5 into 7. When I go to last element again plus. So third element to third element. What is that? 6 into 11. 6 into 11. That's it, Raja. Everything we have multiplied. Okay. So when you simplify this, you will be getting the answer. Very important what I said, you should listen. Otherwise, you will not understand whatever I said. Okay. Just you have to multiply this. 1 ones are 1. 2 5s are 10. Okay. 3 9s are what, pa? 3 9s are what? 27. Like that. Here 4 ones are 4. Plus 5 5s are 25. Plus 6 9s are what, pa? 54. Right. We have to add later. Leave a gap. Again 1 3s are 3 plus 2 7s are 14 plus 3 into 11 33. This will be 12 plus 35. Again when you multiply this 66. We have to add everything. So when you add, you will be getting the final answer. What is that? 27, 37, 38. And this will be 50s, 90, 100, 110. So 110, sorry, this is 4. Then 70, 79, 83. Add once again 54, 25, 4 again. What will you be getting? 9, 13, balance 1. Okay, 83. That's it. Same manner that side. 33, 14 and 3. Now what you will be getting, pa? What is that? 7, 0, remaining 1, 50. 50, I'm right. So this will be 50. And next, what I'm getting here 66, 35, 12 in the sense, 11, 11 plus 2, 13, balance 1, 7, 10, 11. So 113 you will be getting. So that we got as a matrix 2 by 2 matrix. So this 2 by 2 we are going to get like that. We have said while we are checking the answer itself. See, whether we are checking the order itself, I said we are going to get 2 by 2 matrix. So that same thing we got here 2 by 2 matrix. Have you noticed it? Have you noticed it, children? So very important the way of multiplication. Understand? This is very important the way of multiplication you should learn. Okay. Copy this first. Next we are moving. In the note you have to write. In the note what I'm gonna give. See, suppose A, what I said, A have some different order, B has different order. Na? A, what is the column? B, row must be same, I said. Suppose square matrix A and B are square matrix, means it will be defined automatically. That is I'm going to give. Okay. Note, first point, suppose A and B are square matrix. Square matrices na, then AB and BA are defined. Square matrix means no need to check order. Square matrix na, no need to check order. Okay. Even if A comma B have A comma B have same order, then also AB and BA are defined. Okay, listen. Suppose A and B are same order, then also product of AB, product of BA is defined. Understand? These 2 points are very important. Suppose square matrices A and B, na, then also a product defined. Orders are same, A order, B order same, then also what is the product is defined. Suppose order different, na, that is we have discussed in the definition. Suppose order different, A order M by N, B order N by P, means order is different. Different means I gave one example, 2 by 3, 3 by 2, order is different. Order is different, now how it will be defined? That is what I gave. What is that? First matrix column, second matrix row must be same, then only it will be exist. There are 3 types here then. Square matrix order defined, same order matrix, square matrix multiplication defined. Suppose square matrix na multiplication is defined. Suppose A and B same order also, multiplication defined. Suppose A and B different order, sir, means the previous one. First definition what I said, that you have to check whether the product is defined or what, you have to check. How you have to check? First matrix column, second matrix row must be same. Then only this is defined. Otherwise not defined, you have to say. Not defined. Product is not defined. Our product is not exist. Like that you have to say. Okay. Right. Next point. Next properties will give Raja. Next properties will go. In the note point, one more I will give. People may have doubt actually. Sir, generally in the multiplication, 0 into what, sir? 0 into 2 what, sir? 0. So that 0 matrix if you multiply, 0 matrix if you multiply, here a 0 coming na, any one of the element must be 0. Listen carefully. Two element generally when we product, answer is 0 na, surely one of the element what, either first element or second element must be 0. But in matrices not like that. Means when you product A matrix and B matrix, if you get a 0 0, means 0 matrix if you are getting, 0 matrix if you are getting na, it not necessary A matrix, B matrix, any one should be 0. Okay, A matrix, B matrix, any one should be 0. Like that you don't think, it not necessary should be equal to 0. It is not to satisfy also. Meaning example I will give. Okay, people they will think this is in real number, generally in real number. Then A not equal to 0 matrix and B also not equal to 0 matrix. This is 0 matrix I'm telling. Okay, not necessary that 0 matrix now I'll write matrix itself. 0 0 not necessary. Like that B also not equal to 0 0 necessary. It's not necessary. Sometime it may be different also. Understand? Sometime it may be different also. Example if you want, I will give it. Example I will give. Example for this. Suppose A equal to, if you have a 0, minus 1, 0, 2 if we have, and B equal to we have 3, 5, 0, 0 we have. Okay. 0 0, but sometime it may satisfy, sometime, but sometimes it will true, means this case sometime it will be true, not always. If you are giving A matrix fully 0 0 now, when you product with anything it will satisfy, but not always. That is what I am giving example. When you product A B, what you will be getting, the steps you want write down, that I will be giving here. Okay, so A B when you product, what you will be getting, 0 0, minus 1 2, this step you want write there. Okay, 3 5 0 0. Listen sir, the normal product matrix multiplication I told you how you have to multiply. We should take one row, we should take one row, we should multiply with a column. Have you remember what I said? That is I'm going to show now. Listen, first element with the first element. Have you remember that what I said here? In this one I have explained clearly. Okay, listen. So first element to first element means 0 into 3. 0 into 3. Second element when I go, we should give plus. So second element to second element. Second element to second element means minus 1 multiply 0. Have you noticed? Now one row I took, I multiplied with one column. But same row I should multiply with the second column also. When I go second column, you should leave a gap here so that first element and first element means 0 into 5. 0 multiply 5 plus second element to second element. That is what? Minus 1 to 0. Minus 1 multiply 0. Matrix over. Same manner. Now second row I'm going to take. I'm going to multiply with each column. Okay. First second row with the first column means 0 into 3. 0 into 3. 0 into 3 plus 2 into 0. Second element to second element. 2 into What Paraja? Yes, 2 into 0. So one column is over. Then the same row we have to multiply second column. Okay, then first element of this you have to go. So 0 into 5 you will be getting. 0 into 5 plus 2 into 0. 2 into 0. 2 into 0. That's it. I hope you can notice that every element is multiplying with 0. Have you noticed it? Here 0, here 0. Every element is multiplying with 0. When you multiply, it is multiplying, sorry, when you check, it is multiplying with 0. It will be 0. It will be 0. It will be 0. It will be 0. So you can notice that A and B, it's not equal to 0 matrix, but our answer will become a 0 matrix. Have you noticed it? A and B not a 0 matrix, but our answer became a 0 matrix. That is what I am telling in the third point. Okay, product of AB may come 0, means 0 matrix, but it is not necessary A matrix B matrix must be 0, but sometime it may true. Sometime it may true. Sometime it means suppose any one of the 0 matrix now, when you product every element will become 0. That is also possible is there. Okay, that is what sometime I said it may be true. Okay, be careful in this result. Okay, this each result is very important in the matrix multiplication. Okay, in the matrix multiplication each result is very important. Right, fast and I'm going properties. Later we are going now properties. Are we done, Ma? Can I rub this side, one side? Is anyone writing? Done. Right. Then we'll go properties of multiplication of matrices. Topic: properties of multiplication of matrix. Properties of multiplication of matrices. Okay, so we'll see that. So first property what I gave in the addition of matrices, have you remember? First property what I gave in the addition, first property what I gave, commutative I gave. So in the addition, commutative is possible. A plus B is equal to B plus A, I said. But in multiplication, it is not possible. It's not necessary to be possible. Sometime it will be equal, sometime it will be not equal. That is what I'm not talking about the commutative here. While we are saying that, or else I will give a note point. Okay. So directly I'm going in a associative property. Associative law is a true. Means a product of BC, later you product with A, or a product of AB, later you product with the C matrix. Here this will be true. And the second one what na, distributive law. So distributive law sometime they will be asking in the 3-mark question also. So distributive law over addition or subtraction, maximum addition they will be. So that first point A of B plus C. So when you product A inside now, what you will be getting? AB plus AC you will be getting, or first you add A plus B, C you multiply inside. So that either AC or BC. So this will be what actually called distributive law over addition. This formulas and all you have to memorize, because they will be giving A matrix, B matrix, C matrix in the exam. A matrix, B matrix, C matrix they will give. They ask to check distributive law, like that they will give. So distributive formula you must know, then only you can check. Without knowing distributive formula, you cannot check these things. Be careful here. Next, what is that? Identity, multiplicative identity we are going. Okay, multiplicative identity. Okay, multiplicative identity. So multiplicative identity means AI equal to IA equal to A, where I is a identity matrix. I means I told you that when I'm giving types of matrix introduction, I have explained what is I. I means what? Identity matrix. Okay, identity matrix, where I is identity matrix. Identity matrix. Okay, that's it. So this three is very important. In the node pointer, in a node, first point. So what is that? What we can give commutative, or else directly I'll write AB not equal to BA means matrix commutative not possible. Okay, matrix commutative is not true, but sometime it will be true. Second point, but this is in multiplication, okay, but AB equal to BA, what is A and B is a diagonal matrix, okay, when A comma B are, listen, diagonal matrix, A and B are diagonal matrices. Sir, listen, sir. Generally, A and B, it's not commutative in a multiplication. Generally, it is not commutative in multiplication, but AB and BA will be equal, means it will be commutative when A and B are diagonal matrices. Diagonal matrices, when we have, it will be commutative. Okay, or else inverse, when it is comes inverse also, it will be true. A is inverse of B, B is inverse of A also, it will be true. But when we're talking about inverse, that I will explain. Now till this it's enough. Okay, right. That's it, Raja. These all points you want to know about matrices before going to 3.2 exercise. Okay, in next video we'll see what is that exercise. Understand? Thank you, children. Bye.